In this video, you will see me unpack two standards. I have chosen to unpack these standards because they are all aligned with a unit that I'm about to teach. These standards come from the Common Core State Standards for Math 8. We're going to dive deep and look at Standard 8FA3, specifically where scholars give examples of functions that are not linear. Then we're also going to look at standard 8GC9, where scholars are expected to know the formulas for the volumes of cones, cylinders, and spheres, and use them to solve real world and mathematical problems. Mastery metrics. Scholars are expected to know that a piecewise linear function, a nonlinear function, is a function whose graph is pieced together out of line segments. They should also know the volumes of a cylinder, cone, and sphere are V equals BH, V equals 1/3 pi r squared, and V equals 4/3 pi r cubed, respectively, and they can be used to solve real world problems related to functions. Scholars should be able to show examples of nonlinear functions using multiple representations, tables, graphs, and equations. They should also be able to compare the characteristics of linear and nonlinear functions using various representations. And closer here to the bottom, they should be able to state formulas of cones, cylinders, and spheres, and use formulas of cones, cylinders, and spheres to solve real world and mathematical problems. Big ideas. As we go through this unit, scholars must always keep in mind that a function is a rule that assigns to each input exactly one output. Functions can be represented in four different ways: algebraically, graphically, numerically, and by verbal descriptions. They must also keep in mind volume is a unit of measurement that indicates the number of cubic units a three-dimensional shape can hold. As we go through the units, we're going to constantly think about why does one need to define a function? When should functions be evaluated and compared? And how can one use volume to solve real world and mathematical problems? I have picked two lessons to focus on for this unit. The first lesson, Sweet Tooth, the driving question is how much Halloween candy should you eat? Students will learn many people's enjoyment of something pleasurable like Halloween candy or income is not positively linear. More of a good thing is not always better. This activity is broken up into two parts. Act one, scholars interpret a graph showing the marginal enjoyment two people experience. They share their expected marginal enjoyment. In Act two, students graph each person's total enjoyment and they watch a video in which psychologist Daniel Kahneman describes the relationship between income and happiness. A second lesson that we're going to do when we do this unit has the driving question. Well, it's called bottled water, and it has the driving question: what's the best size of disposable water bottle? Scholars will learn millions of tons of single use plastic water bottles have ended up in the oceans and are wreaking havoc on wildlife. This lesson is also divided up into two parts. In Act 1, students approximate the volume of water bottles and they calculate how many bottles of each size one would need to drink to meet doctors' recommendations for daily hydration. In Act 2, students find the surface area of plastic in each size bottle and they identify consequences of single use plastics. These lessons are both cross curricular lessons, which allow scholars to use information acquired in previous courses and apply it here for these lessons, and also learn new ways to apply their knowledge to real world cross curricular problems. In order to ensure that scholars are mastering the standards, I have designed daily cool downs. So every day, scholars take a quick little mini assessment. And for my advanced level scholars, their assessment has more parts, and it allows me to use their advanced literacy level to assess their mastery of the math standard. In this cool down, you see that these scholars will relate graphs, scenarios, and tables, and the scholars will also create their own graph. For the same lesson, my on level scholars will match scenarios and tables, and they will also analyze a graph in a multiple choice fashion. For my SPED scholars, they will have less questions to answer, but they will also relate tables, scenarios, and graphs. And this lesson has a lower literacy level. It's about third grade, and this will ensure that the literacy does not hold the scholar back from showing their understanding of the standard. For my ELL students, I have ELL students on multiple levels. However, in terms of language support, they will get a vocabulary card. It will be a video card where they can just click on a link and they will see the words and the definitions, and I will actually read the words and definitions to them. My ELL students could be doing any of the three cooldowns I've shown, depending upon their level. Also, here's another example of a cool down where we look at the standard related to volume. My advanced scholars will be reading a scenario and then solving real world problems. For my on level scholars, they'll actually be using the radius or the diameter to figure out the volume of a sphere. My SPED scholars will do a very similar cool down to the on level scholars, except for they will be provided with the formula and they will only have to do two problems. Also, they will be given extra time. And once again, my ELL students will get a digital video card where I will give them the vocabulary words, the definitions, and here an actual picture. And depending upon their level, they will complete any one of the three previous cooldowns. Thank you so much. I hope this information was helpful.